This is SpaceTime, Series 20, Episode 53. Coming up on SpaceTime, new evidence that the fastest stars in our galaxy are all aliens. Solving the mystery of why quasars suddenly begin twinkling violently. And why humans are hardwired to see a haunting face on Mars. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has concluded that the fastest moving stars in our galaxy were originally alien stars from other galaxies which were cannibalised by the Milky Way. Galaxies are known to grow through mergers and collisions with other galaxies. For example, right now the Milky Way is drawing a steady stream of stars and gas from two neighbouring galaxies, the Large and the Small Magellanic Clouds. It's also cannibalising another galaxy, the Sagittarius Dwarf. And the Milky Way itself will collide with and eventually be consumed by the much larger Andromeda galaxy M31 in about 3.7 billion years from now. This new study claims a large population of very fast-moving stars in the Milky Way originally started out in a neighbouring galaxy, the Large Magellanic Cloud. The findings, reported in the monthly notices of the Royal Astronomical Society, help explain why these stars are often travelling at speeds fast enough to escape the Milky Way's gravitational pull. It's thought these fast-moving stars, called hypervelocity stars, were able to escape their original home when the explosion of one star in a binary system caused the second star in the system to fly off with such velocity that it was able to escape the gravitational pull of the Large Magellanic Cloud and then get scooped up by the Milky Way. Astronomers originally thought these hypervelocity stars, which are usually large blue stars, spectral types O and B, may have been expelled from the centre of the Milky Way by its supermassive black hole, Sagittarius A star. Other scenarios involving disintegrating dwarf galaxies or chaotic star clusters have also been used to try and account for the speeds of these hypervelocity stars. The problem is all three of these mechanisms fail to explain why these stars are only found in specific parts of the sky. So far, about 20 hypervelocity stars have been observed, mostly in the Northern Hemisphere, although it's highly likely there'd be just as many in the Southern Hemisphere. The study's lead author, Douglas Bubert from the University of Cambridge, says earlier explanations for the origins of these hypervelocity stars simply weren't providing satisfactory answers. One of the big stumbling points is that these hypervelocity stars are mostly found in just two constellations, Leo and Sextans, and Bubert wanted to find out why. An alternative explanation of the origin of these hypervelocity stars is that they're runaways from a binary system. You see, in any binary star system, the closer the two stars are, the faster they're orbiting each other. Now, if one of those stars reaches the end of its life and explodes as a supernova, it can break apart the binary system with the remaining star then flying off at the speed it was orbiting. The escaping star is known as a runaway. And runaway stars originating in the Milky Way aren't fast enough to be hypervelocity because blue stars can't orbit close enough without the two stars merging. But a fast-moving galaxy could provide the energy to accelerate these hypervelocity stars. And that's where the Large Magellanic Cloud comes in. It's the largest and fastest of the dozen or so dwarf galaxies currently orbiting as satellites around the Milky Way. And it only has about 10% the mass of the Milky Way, so the fastest runaways born in this satellite galaxy could easily escape its gravitational pull. The Large Magellanic Cloud orbits around the Milky Way at about 400 kilometres per second. And like a bullet being fired from a moving train, the speed of these runaway stars is the velocity at which they're ejected from their orbits, plus the velocity of the Large Magellanic Cloud itself. And when you combine those two figures, it's enough for them to become hypervelocity stars. This hypothesis also explains their position in the sky, because the fastest runaways are ejected along the orbit of the Large Magellanic Cloud, which is towards the constellations of Leo and Sextans. The researchers used a combination of data from the Sloan Digital Sky Survey and from computer simulations in order to monitor how hypervelocity stars could escape the Large Magellanic Cloud and end up within the Milky Way. To start with, they simulated the births and deaths of stars within the Large Magellanic Cloud over the past 2 billion years. And they noted down every simulated runaway star. The orbit of these runaway stars after they were kicked out of the Large Magellanic Cloud was then followed by a second simulation which included both the gravity of the Large Magellanic Cloud and that of the Milky Way. These simulations allowed the research team to predict where in the sky you'd expect to find these runaway stars from the Large Magellanic Cloud. The study indicates there'd be about 10,000 of these runaways spread across the sky, and it turns out most of them would be seen towards the direction of the constellations Leo and Sextans. About half of the simulated stars which escape the Large Magellanic Cloud are travelling fast enough to escape the gravity of the Milky Way, making them hypervelocity stars. So, if the previously known hypervelocity stars are runaway stars as well, it would explain their positions across the sky. But the story doesn't end there. These massive blue stars are known as spectral types O and B, and these stars are so massive they burn through their nuclear fuel supplies very quickly, and because of their mass they then explode in core collapse supernova explosions. In fact, these stars are often referred to in astronomical terms as the James Deans of the stellar evolutionary tree. They live fast and die young. These massive blue stars end their lives by collapsing into a neutron star or a black hole. And the computer simulation supported this, showing most of these runaway stars died in flight after being flung out of the Large Magellanic Cloud. And what all that means is that right now there is a huge population of neutron stars and black holes flying throughout the Milky Way galaxy. The authors are now waiting for confirmation from the European Space Agency's Gaia satellite. It'll provide a report of data on billions of stars in the next year. If the authors are correct, the Gaia data will provide evidence for a trail of hypervelocity stars across the sky between the constellations Leo and Sextans in the north and the Large Magellanic Cloud in the south. I'm Stuart Gary. You're listening to SpaceTime. A new study has concluded that gas filaments surrounding stars like strands of a pompom appear to be causing quasars to suddenly begin to twinkle violently. The findings reported in the Astrophysical Journal could finally provide scientists with an answer to the 30-year-old mystery of why some quasars suddenly start to violently twinkle. Quasars are powerful beams of energy generated by ancient supermassive black holes as they feed in the distant universe. Material from a passing gas cloud or star that gets too close to the black hole can get caught in the black hole's gravitational well. This material then falls onto an accretion disk around the black hole, where it's ripped, crushed and torn apart, releasing huge amounts of energy, before eventually passing a point of no return called the event horizon, from where it will fall forever into the black hole's singularity. Now, all that released energy is channeled along magnetic field lines into powerful beams, which jet out into space perpendicular to the black hole's accretion disk. These jets shine in all frequencies, from radio waves through to X-rays, and are bright enough to be seen across the universe. They're among the most distant objects we can currently see. Occasionally, when astronomers study quasars, they detect a sudden mysterious twinkling in the quasar. This quasar twinkle effect was first recognised in the 1980s. Stars, of course, twinkle at night, but that's caused by different layers of air in our atmosphere, causing the starlight to focus and defocus. Now, in the same way, astronomers think quasars twinkle when streams of warm gas in interstellar space focus and defocus their signals. But until now, it's been a mystery as to what those streams were and where they lay. Most often, it's a slow and gentle twinkle, causing only small changes in a quasar's brightness. However, occasionally, the twinkling can be extremely violent and unpredictable. Now, a team of astronomers led by Dr. Mark Walker from Manly Astrophysics observed one of these violent quasar twinkling episodes using the CSIRO's Compact Array Radio Telescope at Narrabri in northwestern New South Wales. Walker's team were studying quasars when they saw one called PKS 1322-110, which began to dim and brighten widely at radio frequencies over a period of just a few hours. The authors were then preparing to have a closer look at this twinkling quasar using one of the Keck Observatory's giant 10-metre optical telescopes in Hawaii, when they realised this particular quasar was very close to the hot star Spica. And that reminded Walker of another violently twinkling quasar, J1819 plus 3845. It was close in the sky to the hot star Vega, something previously noted by other researchers. Two hot stars, each near a violently twinkling quasar, was too much of a coincidence to ignore. The authors then re-examined earlier data on J1819 plus 3845, and also on another violent twinkling quasar, PKS 1257 minus 326. And lo and behold, they found this third quasar also happened to lie close to a hot star called Alkane. The chances of having 3 violently twinkling quasars each near a hot star is about 1 in 10 million. One of the study's authors, Dr. Hayley Bignell from the CSIRO, says detailed observations of the 2 earlier violently twinkling quasars showed that the twinkling appeared to be caused by long, thin structures. The findings suggest that very hot stars are surrounded by a throng of warm gas filaments all pointing towards the star. The authors hypothesized that these stars are probably similar in structure to the Helix Nebula. The central star in the Helix Nebula is surrounded by a swarm of cool globules of molecular hydrogen gas, each about as big as our solar system. Ultraviolet radiation from the star blasts these globules, giving each a skin of warm gas and a long gas tail flowing outwards. The thing is, these globules are hard to see because they don't really emit much light, so they could be really common in these environments, but it simply escaped previous notice. The star in the Helix Nebula is already in its death throes, and astronomers assumed that these globules arose late in the star's life. But these new observations suggest that these same sorts of globules could also be around much younger main sequence stars as well, possibly dating back to the time of the star's formation or even earlier. Main sequence stars are those fusing hydrogen into helium in their cores, the process which makes stars like our sun shine. Once stars use up all their hydrogen core fuel supplies, they begin fusing helium into progressively heavier elements, such as carbon and oxygen, causing the stars to expand and eventually turn into red giants. At this stage in their evolution, the stars no longer considered to be on the main sequence. The authors say these new findings have prompted them to begin a detailed search for very hot stars near other violently twinkling quasars. To find out more, Andrew Dunkley is speaking with Dr. Fred Watson from the Australian Astronomical Observatory.
Twinkling quasars. What indeed are twinkling quasars, and where do we find them? I'm guessing in space.
That's absolutely right, yes. And in fact, a long way away in space, because the thing about quasars is they are generally very distant objects. That's an interesting aspect because we don't really see quasars in the nearby universe. And what that's telling us is that they are kind of extinct now. Quasars are no longer phenomena that seem to occur. They seem to be very much the property of fairly youthful galaxies. So I sometimes call quasars delinquent galaxies because what they are is young galaxies which have a very voracious and active black hole at their center. The black hole is gobbling up lots of gas and dust and probably a few baby stars as well in a swirling disk of material around it. And as this stuff swirls around, the material emits, well, a number of different kinds of radiation, X-rays, for example, infrared rays, and most notably radio waves. And so quasars have been observed, in fact, they were first discovered by observing them with radio telescopes. So this is a story about very distant objects in the universe being observed with radio telescopes. We don't really need to know more about the quasars. What's more interesting is what happens to their radio waves as they make their way to Earth. Because we've known for a number of years, well, probably 30 years, that quasars, when we observe them with radio telescopes, they twinkle in the sky. And by that, I mean their brightness, their radio brightness rises and falls over matters of a few hours. And it's a kind of analogue of the twinkling that we see when we look at stars. You know, stand outside in Dubbo or Sydney or Indiana or wherever you happen to be, you will, especially if you see stars low down on the horizon, you'll often see them twinkling. And that twinkle is not a property of the star itself. It's caused by the fact that the light has come through the Earth's atmosphere. The Earth's atmosphere is turbulent. It's got pockets of warm and cold air in it. And they basically focus and defocus the light from the star, causing the twinkling effect. It's very, very pretty, although it's the death knell for astronomers.
Yeah, well, it's kind of dispelled a myth I always believed as a kid. I don't know who told me, but they said if it's twinkling, it's a star. If it's not twinkling, it's a planet. Now,
there's a degree of truth in that.
Is that right?
Yes, because particularly the larger planets like Jupiter and Saturn, they tend not to twinkle. And the reason, it's a complicated reason, but it's because they have, unlike a star, which is effectively a point source, a point of light, planets have actually what we call an angular regular diameter. They have a size, if you point a telescope at them, you can actually see a disk. And what that does is it inhibits the twinkling. The exception to that is Mercury, which is a small planet and is often seen low down in the sky. I've seen Mercury twinkling many times, so you can't guarantee that a non-twinkling object is a planet, but it's certainly true for Saturn and Jupiter. Anyway, going back to the twinkling, as I said, it's caused by this disturbance in the atmosphere. Now, the twinkling of quasars is caused by a kind of analogous thing as the radiation from the quasar passes through pockets of warmer and cooler gas in our own galaxy. Now, the gas between the stars, we call it the interstellar medium, that is very rarefied. It's not sort of high-pressure gas like the Earth's atmosphere. It's a very, very tenuous gas, but it's still, there's enough of it to have this twinkling effect on the radiation coming from quasars. So much has been sort of reasonably well understood. But what is more puzzling is that from time to time, one or two quasars seem to exhibit sudden and quite rare outbursts of really violent twinkling, where their brightness increases dramatically and decreases dramatically. It's called violent twinkling. That's what they give the term to it. So it's a very almost startling effect, which has not been understood. So what's now happened is a group of scientists, principally in Sydney, in fact, although there are collaborators in the USA as well, they've used one of the Australian radio telescopes, the Australia Telescope Compact Array, to look at twinkling quasars and analyze the way the twinkles work. And they can tell that what's happening is the radiation is passing through not a sort of blob of warmer material in the interstellar medium, but something that's shaped much more like a piece of spaghetti, something long and thin as the radiation passes through it. The next thing they did was decided they'd have a look at these quasars with an optical telescope, one that uses visible light. In fact, they were planning to use the Keck telescope in Hawaii. But as soon as they did that, they realized that their twinkling quasar was very close to a bright star, a fairly youthful bright star, actually a hot star by the name of Al-Kahim. It's a bright enough star that it was known to early people.
Wow.
And then they realized that another twinkling quasar is close in the sky to another bright young star, actually the star Vega, which is also a hot star. So they've suddenly twigged the fact that these quasars, they're not close in space to these stars, but their line of sight is close to these hot stars. And that kind of caused them to think about whether these stars themselves might have something around them that is actually disturbing the light of the quasar. And to cut a long story short, they built this theory that suggests that these stars have almost like spikes of material coming from them. In fact, it's slightly, I'm describing it in a slightly incorrect way, because what they envisage is blobs of material coming from these young stars, which have got a long trail streaming out behind them, and that's being blown away by the ultraviolet radiation from the star. So if you imagine all these spikes of material kind of pointing inwards towards the star, that is what they're hypothesizing. That would certainly solve the quasar twinkling problem. However, that's news to most stellar scientists, that's to say the people who study stars, because while we expect to see these inward pointing filaments, we only expect to see them in very old stars that are surrounded by a cloud of gas known as a planetary nebula. We see many examples of that. So it's kind of a step in the dark to postulate that these things appear around young stars as well. They're too faint to be seen. We can only detect them by the quasar twinkling. So it's a very nice piece of work, which is sure to set a lot of people debating whether it's actually the fact or not. But twinkling quasars, it sounds like good news to me.
And as always with a new astronomical discovery, a whole array of new questions now need to be asked and answered. So, it's a never-ending cycle, isn't it?
It is, that's right. So a discovery like this will indeed prompt a lot of research, particularly among the star community, because astronomy is divided into different branches, who'll be looking at these things in detail and saying, how can we make stars do that? So a lot of work to come.
That's Dr. Fred Watson from the Australian Astronomical Observatory speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. If you want more Space Time, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and other things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, and on Facebook just go to www.facebook.com/spacetime with Stuart Gary. The launch of one of China's most powerful rockets, the Long March 5, has ended in failure, with the launch vehicle experiencing what Chinese media are describing as an anomaly 6 minutes into the flight. The mission, which was launched from the Wenchang Space Centre on Hainan Island off the southern coast of China, was the second only orbital flight of China's new heavy lift launch vehicle, which was meant to be the showcase of Beijing's growing space ambitions. The 62-metre tall rocket was carrying the 8,000-kilogram Shenzhou-18 experimental telecommunications satellite, itself designed to be a technology demonstrator. During the live broadcast, China's state-run media kept describing the mission as proceeding smoothly, even claiming normal stage and spacecraft separation. However, that's not what the computer screens were telling mission managers, with flight parameters appearing to be well off target early in the launch. It took almost an hour before Beijing's state-run Xinhua news agency finally admitted that the mission was a total failure. The only clue so far are reports of a plume of gas seen emanating from the Long March 5's core stage about 6 minutes into the flight. The Long March 5 is a two-stage liquid-fueled rocket equipped with 4 strap-on liquid-fueled boosters capable of launching up to 25 tons into low Earth orbit and 14 tons into a geostationary orbit. This failure is bound to have a significant impact on China's space program and what they show the rest of the world. As well as building a space station in low Earth orbit, China also has ambitious plans to mine the moon for helium-3 and to send a scientific mission to Mars. One thing you can almost certainly be sure of, live rocket broadcasts will almost certainly be off the agenda for China for some time to come. This is Space Time. I'm Stuart Gary. Arianespace has successfully undertaken its 7th launch this year. An Ariane 5 rocket carried 2 telecommunications satellites into orbit from the European Space Agency's Kourou spaceport in French Guiana.
Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage UAP, décollage. Les paramètres bord sont nominaux.
18:15 and right on time, well, with a 5-minute delay. Ariane 5 began her mission lifting off
La propulsion est nominale.
in French Guiana with a lot of fire. The DDO is saying that everything is going smoothly on board as Ariane begins her mission, the 7th for Ariane Space.
Tous les paramètres à bord sont normaux.
2 new satellites for new services for new customers around the globe. The 2 boosters are providing 90% of our thrust right now, propelling the launcher along her trajectory at an ever higher velocity. 774 tons is her mass at liftoff. She's burning 5 tons of fuel per second, 2.5 tons in each booster, plus the core stage and the middle is burning another 300 kilos of fuel every second. And Ariane 5 now following the program in her onboard computer, which is located on the upper stage. This gives all the orders, including stage separations, which we will
La propulsion est nominale, la trajectoire est nominale, tous les paramètres à bord sont normaux.
Propulsion and trajectory normal, says the DDO. We're in the first of 4 flight phases. Ariane, as she heads east across the Atlantic. Right now, the single first stage engine and the 2 boosters are burning. The boosters will each consume 240 tons in just over 2 minutes, another 20 seconds roughly for them to burn. They'll be the first to be extinguished. You'll hear that also,
Tous les
of course, from
paramètres à
the
bord sont
DDO.
normaux.
We're 15 kilometers from the pad here in Jupiter, and the sound is just
Séparation des
coming
deux
over.
EAP.
All right, those are the separation of the two boosters. The DDO confirmed it. Before the boosters are empty, their push diminishes and the onboard computer, the same one, senses this drop in acceleration and separates them, and they fall 500 kilometers from shore into a protected area. French Guiana was in part, remember, chosen as a base for its opening on the ocean, launches posing no threat to local population. We're over 100 kilometers, and we're past 2 kilometers per second. We're getting close to the separation of the fairing, which will be next up. And there we are, right on time.
Séparation de la coiffe.
Kilometers. Separation is given by two pyrotechnic cords. These cords actually remove the fairing by a contained explosion, very small explosion, that pushes the two parts of the fairing apart. We can separate the fairing now. Why? Because we're out of the dense layers of the atmosphere and neither friction nor heating, which could disturb the passengers. Also, we can get rid
La
of any dead
propulsion
weight.
est nominale.
The fairing weighs almost 2.5 tons, so we don't need it anymore. We let it go. Ariane 5, of course, the heavy lift launch vehicle. The other two members of the family, Soyuz, lifting middle-sized payloads, 2 and 3 tons, and Vega, the light lift vehicle for
La
missions of
trajectoire
1
est
ton.
nominale.
Ariane flight VA238 involved a 10,177 kilogram payload. The first satellite to be deployed was what's termed a Condosat spacecraft, comprising two separate payloads on the one satellite platform, the Helixsat-3 and the INMAR-S European Aviation Network. The Helixsat-3 payload will deliver high-definition satellite services to Europe, the Middle East and Northern Africa, while the INMARSAT-S European Aviation Network payload will provide in-flight broadband services for airline passengers across Europe. Built on a Spacebus 4000 C4 satellite platform by Thales Alenia Space, the 5,800 kilogram satellite is equipped with 1 Ka band and 44 Ku band transponders for Helixsat and an S-band multi-beam transponder mission for INMARSAT. It was followed later by the deployment of the 3,477 kilogram Indian Space Research Organisation built GSAT-17 spacecraft, which is designed to provide fixed satellite services in normal and upper extended C-bands. It'll also provide mobile satellite services in S-band and data relay and UHF band search and rescue services. This flight was the 80th successful Ariane 5 launch in a row and the 4th Ariane 5 flight this year. I'm Stuart Gary. This is SpaceTime. The SpaceX Dragon CRS-11 capsule has safely splashed down in the North Pacific Ocean following a month-long stay docked to the International Space Station. It was the first time a previously used Dragon capsule had undertaken a second mission, an achievement which will undoubtedly dramatically improve the economics of commercial spaceflight. The CRS-11 Dragon capsule was also used on the CRS-4 mission back in 2014. The reflight mission, which launched on the Falcon 9 rocket from the Kennedy Space Centre on June the 3rd, delivered almost 3 tons of supplies and hardware to the orbiting outpost. Included was scientific equipment supporting some of the more than 250 research experiments being undertaken aboard the space station by the Expedition 52 and 53 crews. For its return flight to Earth, the Dragon was loaded with time-critical experiments, including a fruit fly experiment, an osteoporosis study, and cardiac stem cell research. The CRS-11 Dragon undocked from the orbiting outpost as the two spacecraft were flying at 28,000 km per hour, some 400 kilometres above Central Australia. The Dragon then undertook 3 engine burns to move it away from the space station and position it for atmospheric re-entry.
And so the robotic arm now being backed away by the crew on board, and the release coming on time at 1:41 a.m. Central, while the station was a little over 258 statute miles over the central part of Australia. So they're now going to back the arm away, and then a series of 3 burns will be executed using thrusters on Dragon to begin taking it away from the International Space Station. And the first departure burn has begun.
In Houston Station, Dragon depart was commanded, and we see VV mode departure.
Houston copies. Station, departure burn 1 is complete. Station, departure burn 1 is complete. Departure burn 2 in approximately 1 minute.
And the visiting vehicle officer confirming the second departure burn has begun.
Station Houston, departure burn 2 is complete.
Don, we'd like to say just a couple words for our friend that we just said goodbye to. Dragon's been an incredible
spacecraft. I could even say it was slathered in awesome sauce. This baby has had almost no problems, which is an incredible feat considering it's the first reuse of a Dragon vehicle. And the science we've done, oh my, the science. Most of the 6,000 pounds of cargo carried was science, and almost all the return cargo are precious samples for discoveries we can't wait to see. In addition, Dragon brought up a host of external experiments. We've added an external platform for science, a neutron star analyzer, and a new solar array that rolled out like a party horn on New Year's Eve. The science of this mission has been non-stop, and we think the scientists will be extremely happy with the volumes of data we gathered for them up here in space in our floating world-class laboratory we call home.
Getting confirmation the third and final departure burn has begun. Again, this just to continue getting Dragon out of the area of the International Space Station, putting it into its eventual deorbit attitude and deorbit positioning.
5 hours later, Dragon undertook a 10-minute engine burn to slow down and begin falling out of orbit. 6.5 hours after undocking from the space station, Dragon splashed down in the North Pacific Ocean under orange and white parachutes some 200 kilometers southwest of Long Beach, California. The next Dragon mission, CRS-12, is slated for August the 10th. And this is Space Time. I'm Stuart Gary. The now famous face on Mars is one of the most iconic images ever taken of the surface of the red planet. But the science behind why people see it as a haunting humanoid face is fascinating. It's now well understood that the face on Mars is nothing more than the result of the interplay of lights and shadows on an eroded hill. Still, that haunting image of a half-lion, half-human sphinx-like face staring out at Earth remains etched in most people's minds. The face on Mars is just one of a number of eerie features in the Cydonia region of Mars to have sparked the human imagination. Other geological features in Cydonia, also carved by erosion by the way, include a mesa shaped like a five-sided pyramid and a complex of intersecting valleys which appear to resemble the ruins of some ancient Martian city. It was the early images of Cydonia, taken by NASA's Viking orbiters in 1976, which first revealed the humanoid face staring back at the spacecraft. When first seen in one Viking image, the face was quickly dismissed as nothing more than a trick of light and shadow. However, a second image from a different angle also showed the same face-like feature. And that made things start to appear to be just a little bit spooky. Cydonia, you see, lies in the northern Martian hemisphere, in the transition zone between the heavily cratered southern regions and the smooth northern plains, which was once the floor of a great Martian northern hemisphere ocean. So the region's location on the shore of an ancient sea further added to the human imagination and the idea that Cydonia could be the ruins of an ancient city dating back into antiquity. Speculation about the face on Mars, the pyramid and the ruined city features in Cydonia have inspired many conspiracy theorists and those interested in UFO sightings to develop a range of narratives of long-lost ancient Martian civilizations, and then linking that to existing legends of Atlantis and ancient extraterrestrial cultures that passed on their building techniques to the ancient Egyptians, Mayan, Aztec and Inca. A clear scenario for inventions like chariots of the gods. Decades later, the Red Planet saw the arrival of NASA's Mars Global Surveyor and Mars Reconnaissance Orbiter spacecraft, as well as the European Space Agency's Mars Express, and the opportunity was taken to once again take a look at the Cydonia region. And the modern high-resolution cameras on these spacecraft allowed astronomers to create detailed three-dimensional images of the face on Mars feature. An analysis of the multiple images of this feature have revealed natural-looking Martian hills, whose illusionary face-like feature depends on the viewing angle and the angle of illumination, confirming once and for all that it was indeed just a play of light and shade. The optical illusion of a human-like face is caused by a psychological phenomenon known as pareidolia, which is hardwired into the human brain. Aaron Segev is president of Australian Skeptics.
Pareidolia is when people notice patterns where none exist. For example, we see a face in something that is not a face, like the clouds. So the best example, the most well-known example of pareidolia is the face on Mars. Definitely will be something that listeners to this program will be well aware of. The reason that noticing faces is a particularly good example, particularly common example in humans, is that we are social animals. So we have evolved to notice faces. Noticing faces is critical to our survival. In particular, research has shown that babies seek their mum's face and latch onto it within hours of birth. And you have to remember that babies at that stage, their vision is really blurred, and only they're very short-sighted and it's really blurred. So they only have like a rudimentary vision of the face, but they still latch onto it. They still look for it. Obviously, that creates that connection with the mother. Importantly, what that means is that ability to notice a face, even when it's blurred, when you don't actually know what a face looks like, the baby doesn't know anything. It's built in. It's something that is in our brain when we are born. So this is not something that we learn. It's not something that we absorb from the culture around us. This is something that we're born with.
What about people who have bad facial recognition characteristics?
A famous example of that is Dr. Carl.
Yeah, that's what I was thinking of.
And there are others. Robin Williams from the Science Unit also has a milder case of prosopagnosia, which is what it is called. But even people who do not recognize faces still recognize that it is a face. So the ability to simply latch onto a face, even if you don't recognize who the face belongs to, is something that is built in. And I don't know that there are exceptions to that unless with severe brain damage.
Recently, Hubble took a great example of gravitational lensing, where we saw a couple of galaxies being lensed, background galaxies being lensed by foreground galaxies. It made a smiley face. Everyone could see it was a smiley face. It was actually a couple of galaxies being gravitationally lensed.
Absolutely. The thing is, we see faces anywhere. On the Wikipedia page for pareidolia, there's a lot of examples of rocks and craters and clouds and all kinds of things. We just see them immediately. And there's some really funny examples. So obviously there's
Jesus on a piece of toast and things like that.
Yes. Yeah. Well, but obviously we know about the face on Mars, which is a famous photo that was taken by the Viking spacecraft on Mars and looked very much like a face. However, many years later, a photo was taken of the same region and under different lighting conditions, and all that's left is just a rock. So it just looked, because of the angle of the sun, it just looked like there were eyes and a nose and maybe a bit of the frame of a face. And our brain did the rest and converted it into a face, and that's why we call it the face on Mars. There's really funny examples. For example, on Google Street View, an example I saw recently was a picture of a house. So there were two windows, a little bit high up. And then in between them, there was a rubbish bin just placed halfway between the two windows. And Google Street View generally automatically blurs faces. And it blurred that because it looks a bit like a face. Now, this is actually really striking because Google actually have excellent face recognition algorithms. They use this to allocate photos to faces in their Picasa software, and they do a really, really good job. So they're able to say this face belongs to that person, but they still sometimes will do things like recognize as a cow as a face, or in this case, a building. So obviously this is something that is really profound because they try to emulate the human brain in the way they recognize faces, and that's just what happens in these cases.
So this must all have originated as a survival technique. Really important in ancient times when we were chasing our dinner across the savannah, I take it. We wanted to make sure that we could see our dinners out there and we could see any potential threats that were chasing us.
Absolutely. So noticing a face where it's not really a face. If you think about it, what it means is that we see something that does not exist. It's called a type 1 error.
They're the type 1 errors. What are the type 2 errors?
Type 2 errors are when we fail to notice a pattern that does exist. But humans are much more prone to type 1 errors, and I think that is actually quite understandable when you think about the evolutionary perspective. So think about a pattern such as hearing rustling in the leaves. Okay, you could assume that there's someone there, someone or something there, maybe an animal. And then if you think about our human ancestors out in the savannah in Africa, and she hears rustling in a nearby bush, and she suspects it's a tiger, and decides to run away. If she is wrong, meaning she thought it was a tiger, but it wasn't, she's basically made a type 1 error.
No harm done, but.
No harm done.
Bit sweaty. That's about it.
Yeah, she's a bit sweaty, but otherwise no harm done. However, if she ignores the rustling and it turns out to be a tiger after all, which is a type 2 error, okay? You basically, you do not detect something that is there. That's the end of her overly confident bloodline. Basically, her genes do not make it to the further generation, which means that those who make the type 1 error are much more likely to pass on their genes. And that's how evolution works, which is the reason that we have all evolved to make type 1 errors, and pareidolia is a very, very common type 1 error.
We see it in other animals too, don't we?
Well, as we just discussed, evolution works not just on humans, obviously. I would expect basically type 1 error to be universal in all animals because it is so evolutionarily advantageous.
That's Aaron Segev, president of Australian Skeptics, looking at the phenomenon of pareidolia. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, your favourite podcast download provider, or direct from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio, and as part of Virgin Australia's in-flight entertainment. If you want more space time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and other things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. Subscribe at iTunes, Stitcher, Pocket Casts, or Audio Boom. This has been another quality podcast production from Bytes.com.